some fancy transitioning. Okay, so I'm just going to jump right in. The reason why we have this meetup is because me and Federico and Simona has been accepted to talk at the REX conference before KubeCon. And the REX conference is a conference where everyone that got rejected to the real KubeCon was able to send in their call for papers as well. And we got accepted to speak at the REX conference, which we're very happy about being rejects. That is like the setting for this session, and we're very happy that you will be here and hear us rehearses. And I want to talk to you about getting developers to adopt your service. And I have the mandatory me slide. Before I had one slide that said something about me. This one is the upgrade from that one. I want to tell you that if you want to reach out to me, you can reach out to me in the Kubernetes Slack. I'm Jessica. That's plain Jessica. I'm the only one named Jessica, more or less. Or at Twitter by SolidTubes. There will be an ending slide as well if you want to look at it again. I've been with Meltwater for 3 years, and I've been on the Kubernetes project since we started it a year and a half ago. And it's been very fun to be with it on the start from the beginning, and it's been a long run, let's say that. And I'm happy where we are today as well. I will tell you a bit about in this session how we went from starting the project until getting our fellow developers to adopting the service that is Kubernetes as a service. That is what this talk is going to be about. So where do I come from? This is the company I work at. It's called Meltwater, and we provide localized insight and dedicated support to clients across the globe. And we help you monitor your brands and social marketing, and we quantify PR impact so you know your share in your industry, and also that you can connect to influencers in that brand. The reason why I tell you this is because what we do is that we gather a lot of data, and we make that available to our customers so they can get more insights. And that is a large infrastructure behind it with a lot of different services. So in the product and engineering department, we're about 450 developers. And these are the 12 biggest tech offices we have around the world. And we are about 50 different development teams spread over all these locations. And once again, the reason why I tell you this is because it's relevant for our problem. We work very distributed, both teams being distributed on multiple locations, but also different parts of our product being distributed. So the team that I'm working on is called, sorry about that, Foundation. And our mission is to enable teams to accelerate without thinking too much about the infrastructure, allowing a rapid path from ideation to prototype to providing business value. That's a lot of business bullshit, but the point is, what we try to do is we try to make it easier for the other development teams. We try to take away the mundane things that every team needs to do so they don't have to think about it. Because there's no reason that each of the 50 teams that are in the different locations need to do and repeat the same type of infrastructure. So we tried to create paved roads, and that is like a set of features or a specific procedure or something that you can do in order to make it easy. So they don't have to do the discovery. Sorry about that. Nice, Ola. They don't have to do discovery of like, okay, so what is the best way to set up my AWS account? What is the best way to deploy Docker containers? What is the best way to have my logs? What we tell them is that this is where you can send your logs, and this is where you can view them. Don't care about anything in between. We take care of that for you. And all these things make that our development teams can spend more time on building a good product rather than spend time, waste time actually somewhere else. And why I care about why people adopt the services that I develop is because if we have a high adoption rate, that means that we built something right. We built something that was easy to use for the teams. We built something that they wanted to use and that solved some of the issues, so they don't have to spend that time there. So for us, high adoption rate is success. We did something right, which is awesome. My team is located in Gothenburg and Budapest. We work with teams from all these other locations. That is one of our problems. time zones. Who here like time zones? Right? So it's like, for instance, when I go home, my coworkers in San Francisco go to work. When they have a question for me, that means that they will have to wait a full workday before I will be able to respond to that. Unless I work evenings, but I don't like working evenings, so, and they don't like waking up too early either, to be honest. So that's one of the biggest challenges that we have, that we will not always be able to talk real time to our coworkers. So, the service, you probably guessed, it's Kubernetes. We started out many years back, before I joined the company, with Mesos and Marathon, because when we started out with container orchestration, this was the way to go. That was the only thing available, more or less. So this is what most of our development teams are used to using. Most of them have still some things running in Mesos Marathon. And this was the first step to autonomous teams for us, because that's not where we come from. We come from development and operations. Moving over to DevOps and have autonomous teams, Mesos Marathon was a great step towards that, because that gave the teams an ability to own their own solution, from the code to the deployment and the lifecycle of the application. And what we're doing currently is that we move people over to Kubernetes, but also new teams and new applications that have not run in Mesos Marathon move to Kubernetes. Right, I wanted to point out one more thing. Some of the expectations our users have on Kubernetes is based on their experience with Mesos Marathon, which means that we have to live up to some things that Mesos Marathon gave them, or our solution for it. So some of the things that we tried and learned. In the beginning, when we started out a year and a half ago, we realized that it would be great if we could work with a team and we could understand what the needs this team have, basically one of the teams in Mesos Marathon, and how they want to use this new service that we're building. So what we did was that we dedicated a full week. We flew in our members of the team that was not located in Gothenburg. The team OWL is a local team from Gothenburg, so the majority of the people were already here. So we gathered here for a full week and worked closely together to see what they would need. We already had a prototype of Kubernetes up and running, but we also moved some of their stuff from Mesos Marathon into Kubernetes to see how that worked out and what we could learn from that. What we learned was two things. Don't have other things happening at the same time, like a very nice karaoke evening. It was a great karaoke evening, but it was a slow day after. We also learned that to have a clear goal for these weeks is important, because at one point it was kind of unclear of what we wanted to gain from having a focus week, as we call it. In the end, it was very valuable, but I think that you need to prepare, and I think you need to have a clear goal, and you need to select a team with care. We picked a local one, and we wanted to be in the same location. I think that was a main point. We have done similar with other teams later on, and it was a great success as well. But this was the first experiment, and we learned a lot. So, time to market. Once again, another buzzword. I hope everyone heard it before. It is true, though. We started talking about Kubernetes in November 2017. It's almost a year and a half ago. From the moment we talked about it, there was a lot of buzz around Kubernetes, and all the teams were like, oh, this will be awesome. When can we start? And when will you be done? And, should I deploy to Kubernetes or Elastic Beanstalk? But I can deploy to Elastic Beanstalk right now. But I have to wait before you tell me that Kubernetes is production ready. No one was running Kubernetes in production. Of course we were not production ready. In the end, that became a challenge as well for us, because we had to catch some teams early on so they wouldn't move to a different solution, which means that we had to rush our Kubernetes development to get to a state where we called it production ready before we really felt we were production ready. And we also had to start convincing teams that had already moved on to something else, because there's many different things. One could be that you don't have time to wait, you want to deploy today. The other thing could be like, hey, tech is cool, I want to play with some cool tech as well. We had teams that tried out later on the Amazon Kubernetes solution and Fargate, etc. And mostly, to be honest, because they found it interesting, they wanted to learn more about it. So the way to learn more was to deploy somewhere. We have full autonomy. We cannot force anyone to use any solution. They can choose for themselves. We can only compete with building a good enough, customized and tailored solution that they want to use. That is the only thing we can do. So being quick and being better is the way we can compete with different solutions. Authentication. When you have users in Kubernetes, you probably want them to authenticate before they can run towards the command stores API. And we have already set up GitHub in our organization. We have a GitHub organization. That's where we onboard every new developer that joins Meltwater. We also have an offboard process. We have teams set up to match the engineering teams that we have, etc. So I know that you can authenticate towards Kubernetes using IAM and many different solutions. But since GitHub is something that is already in place and our developers know and want to use, that was the solution we had to go with. We didn't have a choice, more or less. So we had a great challenge of learning how to use DEX and combine that in order to use it for our users to authenticate towards Kubernetes. My point here being that you need to figure out what is the perfect way for your users, right? Depending on your service, depending on what you have, maybe OAuth with Google authentication is the best way for you to go. But that depends on how your organization is set up, right? And we also had to care about templating, because imagine you write YAML for your deployment. Maybe you have your deployment, you have your service, maybe an ingress. That's fine to write manually and like change. It's also fine when you have maybe 5. It's not fine when you have this many. And everyone just differs with this tiny bit changes. And this is a real use case that we have when our teams are working with natural language processing. That means that they have a different deployment for each language they process. And it's small things that differ, and they don't want to manually have to manage these changes. They want to have a configuration file, and then they want to template these settings. That's not the only thing they want. They also want to use Terraform, because they use Terraform already for the infrastructure, and they don't want to learn Helm, because that's a new thing, and they already use Terraform, so why can't they just use Terraform? Well, because the Terraform Kubernetes provider, it doesn't support alpha or beta features yet. They have changed their mind. They will start supporting beta features. We need to run with beta features in our cluster because of I think DNS and ingress and a lot of different things that we depend on for our production environment. Which means that we have to develop our custom Terraform Kubernetes provider. And that is something we need to do in order to have these teams choose us rather than Elastic Beanstalk, as they currently run with, I think. So these are all challenges that we have done, we had taken into consideration when we try to gain the adoption of our users. And GitOps, remember Mesos Marathon? We had a setup where we had a repository in GitHub where the teams could just change their configuration files, and then we had a Jenkins job that looked at that and made sure that it got deployed into Mesos Marathon. This is a known experience for our developers. This is how they're used to do things. So when we tell them, oh, but you just edit your YAML and then you do kubectl apply on command line, they go like, no, hang on, wait a bit. Why should I change to Kubernetes when I can't automate any of this? So what we did was that we set up Drone. Drone is a CI/CD tool, and integrated it into Kubernetes. And we also gave them a best practice on how to automatically deploy Kubernetes configuration upon pull request merge into master, which made everyone super happy. I think this is the part that I think is the most important one. All tech challenges, it's like, fine, they probably didn't want to use something other than Terraform, but they could probably live with that. But they would not even know about the things we did if we didn't communicate it. We distributed, we need to communicate, because it's not like they're going to walk past our team area and hear what we talk about. That will not happen. So we spend a lot of time on writing documentation. We have a wiki page where we try to update it as much as possible without duplicating Kubernetes official documentation, because that would be useless. We also write blog posts, and we have every 2 weeks we have a sprint review. We record it and publish it on YouTube with a private channel. And we try to record presentations and workshops. This is one of the reasons why I'm recording this talk, because it would be nice to share it with our coworkers. And we also broadcast it. We don't publish it and send it into the void. We also actually make sure that it reaches the users. So we send them like a push notification. We have a Slack channel for each of the services that we own. So we have the Kubernetes Service channel, where we publish like, okay, so this is what we've done. This is what we will show in the sprint review, or here's some new news that you might care about, and stuff like that. And it also works really well, because when they have a question, they come into that channel and they ask us. And sometimes there's a fellow Kubernetes user that actually answers this before we have time, which is really cool. But I think the thing that has made the most difference still is to actually go on location. So we have what we call enablement weeks, where we collaborate closely with a team, and we go to the office where they are, or we gather everyone in one office at least if they are also distributed. And then we spend 1 or 2 weeks with a schedule of things that they want to learn, and we have a clear goal. Maybe it is migrating services from Mesos Marathon into Kubernetes, or it could even be, often we just gather all the services that we own and we talk about all of them during these enablement weeks. But mainly, lately, it has been a lot of focus on Kubernetes. And after this, we go back to the other 3 again, because when they know more and they're more confident, then we'll be able to go back and look at the recordings or the documentation and gain more about it. But when they're just starting out, it could feel overwhelming to look at these things, because it's so much. Unfortunately, Kubernetes is not a simple system. We also actually have twice a year an unconference, internal unconference, where we gather, we aim to gather at least one from each team in the company. And we gather everyone in one location. Last time we had it was in November in Toronto. We had a lot of people in the same location, and we, as a team foundation, we prepare very well. We prepare presentations, we prepare workshops, and we go there and we offer them. We try to be visible and approachable. And by having a presence, people come talk to us and they ask questions that they might not ask if they don't see us. Because have you ever thought, oh, maybe I should just call someone and ask this? Because that's not what people like to do today. Like writing a chat message, even that's a threshold. But seeing someone in the same room, like at lunch, that's when you go ask them something. So being in the same location in these events is very useful for us to broadcast our services and be visible and approachable. And also, it's a great opportunity to see what teams are working on and how we can adapt to make it fit their use cases. These have been all the things that we have been doing, but when shit hits the fan, then what do you do then? I want to bring up a story from 2017, and you probably remember when Gitlab had an outage and they deleted the database, but it was the master, not the replica, and then the backup failed, and then the second backup failed, and then the third backup worked, but it took like half a day to get back. Yeah, that one. They did very well, because I think a lot of us remember them with a positive note after this, because they were very transparent. They shared the postmortem. They had a live stream debugging the issues, and they were very open with the issues they had. And this is very brave, I think, and it's something that I think back on many times. So when we had a large fire, you know Kubernetes namespaces? Do you know what happens when you delete a namespace? All resources attached to that namespace disappear instantly. That means that when you delete all your user namespaces, all the deployments disappear instantly. It's not fun when you do that. So, let's just say it was clean wipe. What we did was that we took inspiration from Gitlab, and we shared our Postmortem. We even like pushed it on all of engineering. We sent an email with the Postmortem to all of engineering. We got this text back. Thank you for sharing this in such a transparent manner. It is great to see what Foundation takes the responsibility for the cluster very seriously. Yada yada. So while the service went down, and that of course is problematic, I actually do trust the service more now due to this communication. This is an actual quote from one of our senior engineer managers in the organization after we published the Postmortem. And I think this is what I wanted to say, that if you have transparency, you actually share what's going on in a calm, coordinated manner, that will actually inspire trust rather than people will get hooked up onto the fact that you actually failed to begin with. They will remember more that you actually showed that we know we did it wrong, we realized why it went wrong, we will not have it go wrong again, and this is the steps that happened. So I want to really say, be transparent with your users, they can handle it, and they will actually like you more for it. And I also think it's important to share the love. I'm not that happy to do it here, but we actually have a secret channel. It's called foo-love in Slack. It's where we share things that people write positive about the services that we have. And I took this one as an example because it made me really happy. It's slow elastic beanstalk deploy is driving me nuts. KTS spoiled me. This is pulled from like a team channel out of context. It was not sent to us. It was a team chatting with themselves. And it made me really happy because this is what we aim for, right? We want people to appreciate Kubernetes more than Elastic Beanstalk or any other services that they can use for running containers. And it makes you know when you succeed as well. So with that, I can take questions if you have any. Yeah?
Was there anywhere along the road where you felt like maybe it's not worth going to Kubernetes?
We were worried when Amazon said that they would. We're stuck in Amazon, by the way. That's one of the pre-phases as well. We don't get out. They announced that they were going to look into making Kubernetes, but they were so slow. It's like they almost didn't want to do it. So that was the only time we were slightly worried when they announced they would look into it, but they didn't make it time to market. Important.
How big is your team? How many?
We are 5 people.
Yeah. And you're only working with Kubernetes, or do you have other things?
We do logging as well.
Yep.
I think Federico will show you some numbers on what we are working on later on, so you will understand the scale we work at, but a bit. Yes.
But are you running your own Kubernetes infrastructure, like your own machines, or are you kind of using any of the cloud providers to run?
We're running in Amazon, so everything is on EC2, running on EC2 instances, but we manage the full setup ourselves, so we manage the masters and the instances.
Why didn't we use Google Cloud Platform?
Sorry?
Why didn't you use GCP?
Oh, because we're stuck in Amazon.
Okay. How do you manage secrets? I guess you had some solution before when you used Mesos Marathon.
Yeah.
So are you using Kubernetes secrets, and do you commit them? How do you manage them in the repository?
Yeah, so currently teams have their, so the question was about secrets, sorry for the recording, how we manage secrets, and we previously had a solution, an open source tool called Secretary for Mesos Marathon that encrypts the secret, and then you can stash it into your repository without fear. That means that you still have to store your secret somewhere else, which teams already have done for many years now. And some use like store them in KMS, I guess, or they store them in 1Password or different solutions to share them within the team. Currently, we don't have any specific tool for Kubernetes. We store them, teams manually upload them to Kubernetes secrets. They don't store them in files, but they like manually add them into Kubernetes.
So also you mentioned that the team members have some expectations when they come from Mesos Marathon. So Kubernetes have to live up to. I don't know. I actually never used Marathon, so I don't know what are the advantage that you need to compete.
I think the main what they had in Mesosmartphone that they are expecting from Kubernetes, and I think the main thing is the GitOps style, because they were used of doing commitments about their configuration and then have it automatically applied and run. So the way they wouldn't rarely go in and as you would do in Kubernetes, you can do a Kubernetes scale, for instance, but they would rarely do that because they would change the number of replicas in the Mesosmartphone configuration, commit that, and once it merged into master, it would be applied. So that is one of the biggest expectations of a workflow that our users had moving to Kubernetes.
For templating solution, are you using some in-house stuff, or are you using other open source solution?
For templating, we currently use Helm, but you remember the big fire?
Yeah.
We don't use Helm releases. We just use Helm for templating, and then we template it and output it into YAML file configurations, and those are the ones that we apply.
Are you looking to customize?
We have looked in slightly to it, but it's not a solution that we have used yet.
So it's the aim that your users get some sort of infrastructure which should be transparent for them. Say, just write code, commit it into a repository, and the kind of pull request gets merged, and things happen.
Yeah, so the teams are responsible for building their own Docker containers, and they have that as part of the build pipeline for most of the time, or I think all the time. And once that is done, they have their own KTest site repositories, and they have in that one a configuration for drone. And then drone will pick up those configurations and run those repositories, and through those deploy to Kubernetes with Kubernetes deployments. So it's still a lot of the responsibility is still on the teams, but they at least don't have to care about where it will run once it's done. They know there's a Kubernetes cluster somewhere, and they deploy to it. But they don't care about the instances in the Kubernetes cluster. They don't care about how much buffer we have in resources. They just care about they get the resources they define in their configuration. Yes.
You have all the environments in the same Kubernetes cluster as well?
We have all the environments in the same Kubernetes cluster, that is correct. We separate by namespaces. So each team has a namespace and one namespace for each environment. So for instance, you have Team OWL, and they have OWL Dev, OWL Staging, and OWL Production. I'm pointing at Ola because he's part of Team OWL. Sorry for that.
How big is your cluster?
Our cluster is currently 250 nodes. 200?
We use
Okay.
the cluster autoscaler, and since then it's dynamically just provisioning the right amount of nodes that we need. Before that we had more, and now it's really just the right amount of nodes.
How big is one node?
It's a 2x large
R4?
right now, which with 8 CPUs I would have some slides later on.
One more question is if you run any stateful service inside Kubernetes cluster?
Yes.
Okay.
We currently run Prometheus as a stateful set inside, and we have a couple of other stateful sets that will not take longer time to explain what they do.
Where do you run your database?
Our databases is usually as run as RDS in Amazon, and then the teams do a VPC peering towards their account, because we have separate accounts by team, and Kubernetes run in our account, and then they run the RDS in their own account, and they peer towards that and connect to the RDS. Though if we run, let's say, Elasticsearch clusters of large scale, then we run those as clusters, self-managed clusters on EC2 instances. Yes.
How do you reason about writing custom code to provide features like the terraform templating? Since this is something that you have to maintain for, I don't know, not really forever, but
Yeah.
for a certain period of time.
So custom code, for instance, the Kubernetes provider for Terraform. This is my personal opinion. I think we should not do it as long as we can. And as soon as they start supporting beta features and the ones that we need, we stop providing Kubernetes provider in Terraform. Because I don't want to do duplicated work, and I think it's much better to contribute to the open source project rather than write our own version of it. Cool. Thank you all. And we'll take a 5, 10, 7? Okay, sorry.
10 minutes.
10 minutes break.
Good. Next session, next talk, next rehearsal for the same conference that we will present the Cloud Native Rejects one. My name is Federico Hernandez. I work in the same team as Jessica and Simone, and then we have Rasmus as well somewhere here. He's hiding, but he's also a team member. Yeah, I work for the same company, and I don't need to talk anything about that one. Jessica did this really good, and I not even really lying because it's plus. So you know that we maintain a Kubernetes service for our developer teams, and Kubernetes is just Kubernetes, but it's not a plain Kubernetes service that we maintain. We add a lot of stuff to it. We use DEX for authentication. We use the Amazon CNI plugin for networking. We use Nginx for ingress. We added external DNS. We monitor it with Prometheus and Thanos, and then we collect the logs with Elasticsearch. And this is basically the not just the paved road, but the autobahn for our users, customers to use Kubernetes. And how we maintain this, and foremost how we upgrade this one so that no one even noticed, that will Simone talk about afterwards. Will talk about this. How do we know that Kubernetes is doing what it's doing? How do we know that it's working? So that not our neighbor team comes to us and picks it out there. I'm deploying this. Our pods are hanging. They have done this actually, and we're really glad for that. But this is the cluster, how it looked like a couple of days ago. At that time it was 145 nodes. We have the cluster autoscaler, so it goes constantly up and down depending on demand. At that time we had 561 deployments there, and they were used in almost 400 services. And we had services of type load balancer, almost 100, and then a couple of other Kubernetes objects like cron jobs and jobs that are used. Stateful sets, someone asked, we have 21 stateful sets in the cluster. And this is the talk about how do we know all these things, and how do we know that this works. So for example, how do we know that our nodes in the logging instance group scale up and down depending on demand? And this is basically the monitoring query that we use for that. So we sum on all the nodes in the instance class logging. I needed to black out some information there. The same here. How many pods do we have in the cluster? Well, we do this query here with the kube-state-metrics Prometheus exporter that I will explain about in a short while. And then we see that our pods go up and down depending on demand. We have HPA usage, and then you see that at some point we had almost 2,350 pods in the cluster. That makes Simone always very happy when we are over 2,000. And this is the query. If this is too small, then you see it here, and I will explain it how you come to this query. So back to the roots. How is monitoring done in Kubernetes? Prometheus is the de facto standard. Who is using Kubernetes? Who is monitoring it with Prometheus? What are you other people doing? You're not monitoring? Good, good. As long as you're monitoring with something, it's good. Don't fly in the dark, in the blind. So, for those of you that don't know about Prometheus, we have the master component here. We have the nodes where all our containers, our pods run, and then we have Prometheus and some exporters. what Prometheus basically does is it scrapes the metrics from each component. So it goes out to the API server and scrapes the metrics. It goes to etcd, the database, the brain of Kubernetes, and scrapes metrics. It goes to kubelet and scrapes Docker via cAdvisor. And it could even go to the pods if they're instrumented and scrape metrics from there. With these exporters, we can get machine node metrics. But with that, for example, when we scrape the API server, you would only get these kind of metrics, latency of the API request and so on. Does this tell you anything about the state of Kubernetes, how Kubernetes is behaving, if it's working? It tells you how much time that your kubectl call took. If we use the node exporter, you will get metrics of memory, CPU usage, disk usage, network traffic. Still nothing about the state of Kubernetes. If we go to the kubelet and cAdvisor, you get metrics about the container. Interesting, because you get the usage of CPU and memory and so on for your applications that you run on Kubernetes. But still nothing about the Kubernetes state. And the same goes when you go to etcd. You get metrics about etcd performance itself, but nothing about the content. And if you go like, you visualize the CPU usage in the cluster on all the nodes, you get this. Not really useful. It's nice to look at it, but it does not tell you anything at all about how Kubernetes is working and behaving. And we want to know about pods, nodes. We want to know about how the deployments are running. Are there pending pods? Are there pods that are crashing? We want to know how the horizontal pod autoscaler is behaving. Is it reaching the maximum of pods that it's supposed to scale up to? We want to know about cron jobs that are running. The services, do they have all the endpoints? What kind of IP addresses are there? Which pods belong to that? And so on. And strange enough, you have this information. You have this information on the command line. If you go kubectl get nodes, you get, for example, the information on the status of all your nodes. They're all ready. They're all running. You pipe this to WC, you can count them. You know how many nodes you have. kubectl get deployments lists you all your deployments and how many pods belong to that deployment. So that information is there. It's on the command line, it's not in Prometheus. You do this, you get 2,349 pods, piping it on the command line to WC. You can even describe the node, get a lot of information on the node that you might want to have on a dashboard. You might want to alert on this. You might want to see it without having to run this constantly. For example, the status of one node. If it's out of disk, the memory pressure, if there is some disk pressure, if the node is ready, you get some labels so that you can start to group them when you count or you want to visualize them. The kubectl describe also puts out information on your capacity on that node. If you would sum up over all this, you grab on the CPU and you add everything, you would get the total capacity of your cluster. You get even information on how many pods are running on that node. So that would be nice to have in Prometheus and then in Grafana on the dashboard somewhere. And so how do we get the stuff that is here and is available through kubectl into Prometheus? And that's where kube-state-metrics comes in. Kube-state-metrics is a Prometheus exporter that whenever Prometheus fetches the metrics from there, kube-state-metrics goes to etcd and pulls out this information. Kube-state-metrics is an official Kubernetes project. It was in abandoned state a year and a half ago, but was then adopted by the SIG, the Special Interest Group Instrumentation, and is now actively maintained. The newest version was released last week, and there are quite a few contributors, and they release constantly every 60 days, something like that. So it's something that you really can use and have in your cluster and depend on. So how does it work? When you install it and you start to query the metrics that it exports, they start with kube_. And then in Prometheus, it will autocomplete everything. You see here the examples. First, the information on cron job, on daemon sets, and on deployments. So how do these metrics now come up? And which of these metrics are available? This is how they are constructed. They start always with kube_. Then they refer to the Kubernetes object, the Kubernetes kind deployment, kind service, kind ingress since last week, and so on. And then the metric, the thing that you want to have the value of. They add a lot of labels, and there's a value. This value is a little bit special in kube-state-metrics. But before we go to that, another example on how these names are come up with. So I went to the documentation. You have a list of all these objects for deployments and so on. I put them in a spreadsheet and I listed them here. And for example, for deployments, there is kube, deployment, status, replicas available. Kube, deployment, status, replicas available. And that's how you do it for these objects. And there are like so many more objects around that. For horizontal pod autoscaler, for persistent volumes, for persistent volume claims, for all kind of Kubernetes objects that you can think of. So the metrics that are exposed by this are binary. They're often either 0 or 1. And they're 0 or 1 depending on if the object exists or if a certain condition is true or false. And what you can do then with that is you often then just sum or count these metrics that exist depending on the value. And this will tell you then the information about it. So let's take a look at this. And if you don't know what these metrics mean, the documentation, this is one thing that I really think that could be better. The documentation does not tell you what the metrics mean. But when Prometheus scrapes the metrics, there's a help text. So just put forward to the service of kube-state-metrics, save one scrape with curl, and then you can grep for this. And it explains you all these metrics types and what they mean. Otherwise, you might need to guess just by the name. So let's do one query. We query on kube node labels. It will tell you all the labels of the node. And you see here the value 1. If we now sum on this, it will sum on all the values that were 1, and you get the number of nodes. And in our cluster with the cluster autoscaler, the number goes up and down. So you take your metric, you sum or count on it, and you have some decent information that you can use. And you can use this either for a dashboard or then alerting if you want. If you have a fixed number of nodes and your nodes count is suddenly perhaps under 80% of what you should have, you could alert on that. Next query. I did the same, took the same metric, but I summed here now by the instance group that we use and the instance type. The instance group is something that we use to cluster our nodes into special groups that are used by our customers, and the instance types are the node type of Amazon. And here you see that we use in the general instance group where all our teams just deploy their stuff. We use R4 large for the moment, and we have 72 nodes. In the logging group, the same type of nodes, we had 59. We have 3 masters, 1 for each instance group and one of each zone, and then we had a monitoring instance group where we run Prometheus on a little bit larger machines to cope with all the metrics, and we had 9 instances there. Still on nodes, we could use node status condition. Node status condition uses 2 labels, sorry. There's condition ready, there's condition disk pressure, out of memory, and so on. But I use now ready, and I wanted to know when is a node not ready, status false. And I sum over that. Here all nodes were ready, and suddenly we get, just before 11, 2300, we get 3 nodes that are not ready. I would assume that they're added by the cluster autoscaler and are currently joining the cluster. After a while, they probably become ready. So, and we don't have any unready nodes anymore. So how can you use this further on? You could use to do something like this. You use all of the condition types. Disk space okay, disk pressure okay, memory okay. You sum over that, and you do it for that is true when the disk space is not okay. And as soon as you have something that is not 0 here, you have a problem, and you could alert on that. We looked at nodes. We can look at services. What is available there? An example here is kube service spec type, and there is a label type that has the values cluster IP, load balancer, node port, and external name. And if you sum over those, then you know what your services that you have in the Kubernetes cluster, what kind of type they are. And here you see that we have almost 400 cluster IP services that probably are exposed through these load balancers and the ingress controller. Node services pods. Another example here. When pods are running, everything is fine. You might want to know when pods are pending, when they're not running. They could even be in an error or crash loop. I look now at pending pods. So we always see here that always some pods are pending and then everything is running. And then here, right before 2300, we get a huge amount of pods pending. What happened before? Do you remember on the slide? We got new nodes. So these pods were pending. There was not enough capacity in the cluster. The cluster autoscaler added new nodes, and when the nodes became ready, the pending pods started to run. Everything is fine. And that is by just summing over kubepod status phase, the phase pending. You can look at all the other phases that there are. Pod has containers. Sometimes they crash, they exit, they finish to run. You could look what the reason was why they was terminated. And I did here another sum by reason, the last terminated reason. And you have completed, container cannot run. For whatever reason, cannot pull the image. There's an error, it just crashes, or it gets killed by the killer. They run out of memory. And we had 39 pods in the cluster that were killed. Actually, last week we looked at this. So for us, perhaps the overall status is nice. For a specific team, they could filter by their namespace, and they could filter by their pod or deployment name, and then they could specifically just look at their own deployment, their own pods, their own containers, and have control over what is going on with their application. Can you read this? Nope. Good. Then I have something to fix until next weekend. Is this color bad? Yes or no? but this is too small. Good. Kube cron job status active. I want to know what kind of cron jobs are running and when they're running. I just sum them up. Whenever a cron job is running, the value gets set to 1, and with the sum I see that the cron job is running. So here we have a namespace. I filtered out some more information here, so it's only one namespace. They have every 3 minutes one cron job. Starting, doing something, going down. Then every 15 minutes another cron job is running. That's why they have 2 cron jobs running every 15 minutes. Could be used by the teams to see if the cron jobs are running or not. For us to see if a lot of cron jobs are suddenly running together, the cluster might run out of capacity. This is also too small. If the other one was too small, this is too small as well. I can fix it until next week. Nice to have a dress rehearsal. What I did here is I combined 4 queries in one on the horizontal pod autoscaler. The horizontal pod autoscaler adapts a number of pods depending on the load that you have. And it can scale a deployment between a minimum and a maximum number of pods. So I wanted to see what kind of minimum and what kind of maximum is set for this. It's set to 4 and to 48. And then what is the current status of pods for that deployment? When the HPA scales it up and down, and you see here it goes up and down, up and down, up and down here the entire time. And you can even query for the condition. If the horizontal pod autoscaler would reach this limit or would want to scale below the minimum, this one would trigger and then it would not be 0 anymore. So you can use this to be notified when your HPA is out of bounds, and either you need more resources or you would be good enough with using less resources. Now I combine 2 different resources. We looked at the kube-state-metrics resources, and before that we had these resource metrics, health metrics like CPU usage, memory usage, and so on. On the top line, I query for the CPU usage, which is this line here. On the bottom line, I query for the request that the user gave to the pods. I want to request that many CPU cores. They request 2 CPU cores here. But what you see, they only use half a CPU. So probably they have over-provisioned this quite a lot. And this makes it visible for them. Could be good. Perhaps just only request 1 CPU and you will still run your application here without being throttled. And overall, the cluster resources that are requested would be reduced, and we would spend less money because we would need less nodes. I did this for the entire cluster. Don't be afraid about this monster query. The top part contains a CPU usage. I do this for 1 namespace and 1 instance group. I want to see all the pods in that namespace running on this type of nodes. How much CPU are they using? And I compare it, I divide it against the requested CPU resources. And I see that they're using about 60 up to 80% of the requested CPU resources. This is much better deployment and configuration. It goes between 50 and 80%, quite good. So the requested CPU matches much better reality of the used CPU. This is a colleague of mine in my team. So he knows what he's doing. We could do this for the entire cluster. We compare requested CPUs to the total amount of CPUs in the cluster. And we see that our customers, our teams in the cluster have requested about 70% of the CPUs that we have in the cluster. I didn't graph the CPU usage against this, but it's much less. It's around here, perhaps half of it, 30%. This is the same thing, just over a longer period of time, for 8 weeks. Here we see something that in the beginning of April, suddenly the requests on CPU go up from between 60 to 65%. We see now that we have requests between 70 and 75%. So people are using our service more, or are requesting more CPU cores to be able to run the applications. So with this kind of information from the kube-state-metrics exporter, we have quite a good insight on what is going on in the cluster, which we don't get from just looking at the pure machine, CPU, memory, disk resources, network. They're also important when you debug something, but with this we come quite a long way. We normally don't look anymore at CPU resources or memory, only when we have some problems. But in the day-to-day thing, this gives us a good overview of what's going on in the cluster. So, to summarize, kube-state-metrics is a Prometheus export for the cluster state. It's available here. The values are mostly binary, either 0 or 1, and then you use them in the queries with sum and count to get information on the overall status. And you filter with labels on your interesting things that you want to look at, either a namespace or node groups or deployments, what you're interested in. And you can use them with a join, the Prometheus join, which is the multiplication of these instant vectors. But think of SQL join, to join results from this kind of queries with the results from these queries. And then you can combine labels to use them in the filtering. And with that, I thank you for being here, listening, and being our guinea pigs. Questions? Yes?
Hi. Yeah, I'm wondering if you also monitor the memory usage.
Yes.
Like you did in the CPU, because I feel like, especially for Java program, they use all the memory, all the matter I request, how much memory I request, they use all of them. It looks like it's really hard to monitor.
Yeah, we have a graph where we see the memory usage in total in the cluster as well, and we have this even for the nodes. And then we have some offenders. Not looking at you, Ola. Yeah, but it's an important thing. But as stated, this last terminated reason is a good indicator as well on why you got killed. You can get the memory usage as well. You can get, I only showed now request CPUs. You can also get request memory, and you can compare the requested memory against the real usage memory. So the possibilities are there to do that. I didn't show that here because we would sit another 15 minutes. But you have the possibility to graph and look at memory. You have the possibility to graph and look at network and disk as well. There are persistent volumes and persistent volume claims metrics in kube-state as well.
I could just add an additional comment, because we are running some Kotlin services, and then we also use Prometheus. So what you get here is only the container memory usage, but then we as an application team monitor like the heap usage, for instance. But that is on our, like we monitor our services and their memory consumption that way.
That is the team's role to do. For us as a cluster operator, you saw that we have 590 something deployments there we don't even know what they're running there. And we don't even want to know what they're running there. We just want to make it possible that they can run whatever they want to run there. If there are problems showing up, we help them to get rid of the problems, and make the application run in the cluster. But once that is done, if it's a Java program or Python or Node.js or something else, we don't even know. More questions?
What do you use for alert?
We use the alert manager for these kind of things. We use Grafana alerts, and then we send them to Opsgenie, and then Opsgenie sends them to our mobile phones.
How many Prometheus pods do you have in your cluster?
We have 3 stateful sets. Prometheus with Prometheus, and we use 3 of them, and then deduplicate the data there, and we want to have 3, so we have a good HA solution, so we don't lose any metrics, and we don't get any alerts because metrics are missing.
Have you dialed in any like good sweet spot for alerts? Because I'm guessing you don't want to get alerted as soon as a node is not ready.
Yeah, we have some of these, but mostly not on the nodes not ready. The side effect of a node not ready is the pending pods. And if we have a certain amount of pending pods over a certain amount of time, we get alerts, and then we look into that. A node can die, and then Amazon will create a new node, or a node can be started up. It might not join the cluster, the pods are still pending, and we get alerted on that. It's another level of abstraction, move away from these nodes. Yes?
It sounds like you have spent a lot of time, getting the right queries and doing the Grafana dashboards. Is this something you contributing back to the available dashboards at Grafana?
Not for the time being. It could be interesting, yes, but our dashboard is quite not special, customized to our likes. And I don't know if it would make sense to put this out as a general thing. I guess it would be more interesting to show what we use, and then people can do their own dashboards. There is this other project, Prometheus, Kubernetes Prometheus Mixin, where they template the queries, the alerts, and the dashboard. But this gives you just a general thing. Normally on our monitor that we have in our team area, we added some graphs that after having some certain problems with something that we wanted to get notified or see when you just pass by that this looks good. You arrive in the morning and you get an overview of this, or we have it in the big dashboard that we can use on our own machines. And these are normally, some of these graphs are tied to the problems that we have seen and that we don't want to get again. But the general ones, like I showed you the one with the node status, they're all kind of implementations for that. So rather than perhaps to Grafana, a blog post would be better to share this. More the thinking rather than the specific queries. Because we have now these instance groups that we use in our cluster. Other people might have only one instance group, perhaps only one namespace, or they have, like we, 70 namespaces or even more. So you would need to tweak them. Yep. One more question, last one.
The graph you showed before with the requested CPU.
Yes?
So that only reports the requested CPU,
Yes.
right? So the actual CPU usage could actually be the same across those lines.
It could be the same, it could be much less below. This was for the total cluster. I had the picture here. This was for one application. Here you see the requested CPU, two CPUs,
okay. Yeah.
but they only use half.
Cool.
half a CPU in general. Not even one CPU at some point. So ideally, they would perhaps lower it to 1. And
So the graph where it increased in April, it only says that more people requested in April.
yes,
It could be the exact same CPU usage.
yes.
Okay.
Or it could be actually more CPU usage.
Yeah.
I didn't show the graph there because it would make the query too convoluted. Good. Then thanks again. 10 minutes breaks, and then Simone will show us how we upgrade the cluster.
Okay, so my name is Simone. I work in the same team. Now you have a little context, which is good. And this talk is about what we do to try to not have one of the fires that Jessica showed. By now you know what we do. This is our mission and what we provide. And we use Kubernetes, and as Federico has already shown, we run a lot of services around this. So although Kubernetes is one part of the story, when we do cluster upgrades, this involves making sure that all of these components are actually still working, because this is what our users expect. They expect to deploy to Kubernetes and have their metrics collected. They expect their logs to be there. They expect their DNS entry to be there. You know the scale of the cluster. You know that we use the Amazon CNI plugin. So what could possibly go wrong with all of these things? There's a lot of things that actually did go wrong. For example, we hit AWS limits while doing the upgrades in test, thank God. CNI plugin, a few times. Kops configuration can be wrong, and can make the cluster unusable. Cross-account IAM, as we said, we use, all our teams have different accounts, so they need to be able to access their ECR registry for their containers. Network connectivity, we have VPC peering that needs to keep working after the upgrade, DNS, and Kubernetes, of course. So the very first time that we tried the cluster upgrade, we ran into this problem, and someone asked when you thought, if there was at any point, any time where you thought this is not worth it here. We were on 196, which is not that old, but this problem basically means that if you do a normal cluster upgrade and upgrade the masters, then all your nodes will lose connection and all the pods will just be descheduled. So you're very happy, you start your deployment to the masters, and everything is dead. So thank God this fix was backported to a version in 1.9, but it was a version way ahead of us, so we still have to upgrade. We don't necessarily have to do to 1.10, but we would have to go to 1.9.10, I think, at least. So we thought, yeah, let's be smart. Why don't we do the other way? We just bring up a bunch of new instances on the new version. We start cordoning and draining the old nodes. So we move the pods to the new instances. These instances have the kubelet fixed, so it won't lose connection to the masters. Then we delete the old instance group. Then we upgrade the masters. Profit. Really? We don't know. This is not really like the suggested way to upgrade the Kubernetes cluster. So how do we actually make sure that this is working? What does it mean that it's working? What is the stuff that our user expect from the cluster to always be there? Of course, the API, but there's a bunch of other things. They know that they want to have the ingress auto-created, the external DNS, all the capability of the cluster should be there while they do the upgrade, not just before or after. So we came up with a bunch of things that we wanted to test continuously during the upgrades, during the tests that we do, so that we can make sure that at any point in time during the upgrade procedure, all of these things are still working. So we do our due diligence. we do the pre-flight checks. We go through all the changes that COPS has made, because COPS is the tool that we use to upgrade the cluster, and that needs to be compatible with what we're actually deploying into the cluster and what was deployed before. A lot of the configuration for COPS is, and for components in the cluster, is actually in the COPS binary. The templating is in there, so we need to make sure that that actually works. We need to understand if there is any API deprecations, change it to the components that will break with our configuration. Check that we don't hit any, or try not to hit the AWS limits, because if we double the size of the cluster, then do we have enough resources, API limits, and then we need to check all the components that we run. The cluster autoscaler, is it still working? People expect that to be working. Is external DNS working? And also, because we have a lot of users, we have to identify any change in the behavior of even just kubectl to communicate, so that people can be aware. So what we do, we validate the configuration, the new configuration in a small cluster, so that we can validate that what we're bringing up with the new version of COPS actually will work. And you've seen already from the previous presentations that we run masters in 3 zones, and we have lots of instance groups, and we monitor. We already collect all the logs and the metrics for the cluster with Prometheus. What we do then, we have a process that continuously exercises the API, and so it creates resources, it creates deployments, it does upgrades to the deployment, scale up, scale down, change the image, and each step is verified that it's actually completed. And we do this from the user perspective, so using the DEX authentication, so we know that that part, the path of the user is actually a happy path. And then we do it through our continuous integration tool, because they also expect continuous integration to work. And we track all the metrics into Grafana, and we annotate every step so that we know what's going on. So we can validate both DEX and the API working. What we do when we do the deployments, they create pods, we create services, we create ingress and elastic load balancers in front of that. We also create service of type load balancer, so we know that we can still do that, which is another capability that the users expected to work. And all the steps are verified and tracked. When we deploy something new and we create an ingress, or we create a service of type load balancer, we exercise also external DNS. And once this is done, we can use a load testing tool to check and load test the application that we deployed. On top of this, we also gather metrics from the production cluster, and we try to reproduce the same kind of load on the cluster. We do it on the same scale for the time that it requires, a few hours. And also the load testing exports metrics that are collected by Prometheus. So at the end of it, we can see that something like this. We can track, for example, each steps at which we change the master, we stop the master, we upgrade the master. We can see that there is errors at this point. One of the deployment failed. And we can see that the requests, we have a constant stream of requests that are actually from the load test that are succeeding, and we get it's dropping down here. And for each step, we do annotate the step in our deployment procedure, upgrade procedure, which is, as we said, we double the size of the cluster, we double the size of each one of the instance groups that we have, and then we move the workload. And we track every action, so if anything starts to go south, we know what was, at which point in our upgrade procedure we were, so we can go down and check what is that is happening. We have the same metrics exposed as the Nginx ingress, so we can see how the deployments are doing, and we can check the cluster. We can check, for example, if there is pods that are not scheduled, and we will always have something because we're continuously deploying, but we can see that it's within a reasonable threshold. And also we can track the duration of each deployment to see that they don't suddenly go super high in time or they take too long. I can also show you in. No, I cannot. Sorry. No.
You need to look on the TV. Sorry.
Ah.
That one is.
So if you look at this, this is something that I did this morning because we're testing an upgrade. So you can see, for example, that at this point, I removed one of the API servers and then started the rolling update and so on. And then you can see at this point here, I had one error. So I failed to do a deployment. And then you can see the scaling events. For example, once we rolled out the new masters, we scaled the new the instance group to double the size. This is a more small size cluster. It was about 20 nodes. And you can also see all the draining action for the nodes. We start draining a node, we end draining a node. And you can see that at one point we have one error. One of the requests fails. So if you want to know what happened there, you can go and check. And this is all because it was a lightning talk, but we have time for questions.
So what versions are you currently upgrading to?
1.11.
1.11? So from 1.10 to 1.11?
Yeah. And there is a few things. For example, you cannot pass the custom metrics flag to the API, which is in COPS. They haven't removed it. So it allows you to put it in the configuration, and it will pass it to the Kube API server, and it will fail. To the kubelet, and the kubelet will not start. So.
And you're right now you're in the process of testing this to do it. Press the button at some point in the future.
Yeah. Yeah, I actually in this the last sprint we pretty much automated that, so it's quite easy to go through all the tests. We already template the cluster definition, so we can spin up a new cluster very easily, and then we templated creating the example deployments. So we go and fetch metrics from Prometheus from the cluster and see how many deployments do we have, how many namespaces, how many ingresses. So we try to reproduce the same amount of resources that we have, use the same amount of requested CPU, memory, create the same amount of pods. It's not exactly the same workloads because it's difficult to reproduce, but at least we try to request the same number of resources and the same amount of memory and CPU, and they all generate deployments that are queryable from the load testing tool.
And is this the first time you've done this kind of thing?
No, we've done it 3 times now.
All right.
So we just every time we make it easier. But this is at the very first time that we did the upgrade. Basically, we had to come up. We made realize that bug that nothing comes for free. Even if the promise is that you do a rolling update, that you still have to understand and define what working means for you, because it's not just Kubernetes, it's a lot of things that you run in it, and your users expect it to work. Doesn't matter.
And they can also use the same procedure to roll out security fixes, impact fixes to the cluster. So the 3 CVs that came up during the last half year, we used the same procedure to fix them, and we had them rolled out within a couple of days, which is quite nice.
So far so good. Generally the comment has been, oh, you did that yesterday, we didn't notice. So
every team is responsible for their applications tolerating that kind of
yes,
rolling upgrades.
So as Jessica was saying, we advocate the best practices, and that part is, there was a slide before like a while ago. This is not my presentation, so this one. So yes, so we advocate the use of bug disruption budget and also lifecycle hooks to give time to the kube-proxy to change, to remove like a service. And that's the result. So we have the load test there, it's 50 requests per second on 4 or 5 or 6 workloads, and we only missed 1 during like rolling out. And this includes rolling out, obviously the draining the nodes means that also the Nginx that is in front, like the ingress controller, it's moved away, and still we only had 1 failed request. That made me really happy this morning. I will stop clicking if you have more questions. Okay, then we're done. Thank you very much.